Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 in just 200 days. Yes, so we are in a journey where we are going to cover every chapter of chemistry. We are going to solve a lot of PYQs and practice many questions, right? So yes, in this journey we have already completed physical chemistry, all the 3 chapters of PU2, inorganic chemistry 2 chapters, and organic chemistry first chapter haloalkanes and haloarenes part 1. So in today's video we are going to do part 2 of the chapter haloalkanes and haloarenes, where we are going to cover the most important topic, that is preparation of haloalkanes and haloarenes. So in this video we are going to discuss different methods of preparation of haloalkanes as well as haloarenes, and we'll also be talking about the physical properties, okay, and then we'll be doing lot of practice questions from here, okay. One more important thing, please join our WhatsApp channel. It is important because the notes of the classes you will be getting in our WhatsApp channel, okay. You can download in the PDF format from our WhatsApp channel, question paper, solutions, everything you will be getting in our WhatsApp channel. So please join our WhatsApp channel. To join this, the link of the WhatsApp channel will be there in the description section of this video. So please go there, download the join the WhatsApp channel, and then you can download all these notes, okay. So yes, now I want all of you to sit with a notebook and a pen and to note down all the important things, all the important reactions, name reactions, everything we are going to discuss. So yes, let's get started now without any delay with remembering our target, that is 60 out of 60 in KCET chemistry, okay. So yes, now coming to as I told you, how are we going to discuss this chapter? Already I have discussed it in the first part. So in part, we are dividing it into 4 parts. In part 1, we have already covered classification, nomenclature and nature of CX bond. In part 2, we are going to cover preparation of haloalkanes, preparation of haloarenes and physical properties. Part 3, we are going to do chemical reactions of both haloalkanes and haloarenes, and in part 4 we are going to do polyhalogen compounds, okay. So today we are in this part, one of the very important topic, okay. So now weightage wise, so it is almost 3 to 4 questions every year you can expect from this chapter, okay. Now coming to today's lecture, that is preparation of haloalkanes, preparation of haloarenes and physical properties, okay. So these are the 3 topics that we are going to discuss in today's class, okay. Now coming to preparation of haloalkanes, so there are 3 important methods of preparation of haloalkanes, okay. So the first one is from alcohols, like using alcohols we can prepare. Second one is by using hydrocarbons, okay, and the third one is from halogen exchange method, okay. So I want everyone to recall this again and again, okay. Preparation of haloalkanes, we have 3 sources from which we can prepare. First is your alcohols, second hydrocarbons, and third is your halogen exchange method. Again, first is your alcohols, second hydrocarbons, and third is halogen exchange method, okay. Now coming to hydrocarbons, again here we have 2 types. From hydrocarbons we can prepare from we can prepare from alkanes and we can prepare from alkenes, okay. So in hydrocarbons, you know, alkanes are also hydrocarbons, alkenes are also hydrocarbons. So using both these alkanes and alkenes we can prepare haloalkanes. Now coming to in halogen exchange method, we have 2 reactions, that is Finkelstein reaction and Schwarz reaction, okay. So this one is overlapping here, sorry. So this is like this, okay, this much is different, okay. So we have from here, from halogen exchange method we have 2 methods, that is Finkelstein reaction and Schwarz reaction, okay. Now let us revise again. Okay, now from alkenes again we have 2 methods, addition of HX and addition of X2, that's all, okay. Let us revise again. Haloalkanes we can prepare by 3 sources, alcohols, hydrocarbons, halogen exchange method. Under hydrocarbons we have from alkanes and from alkenes. In alkenes we have addition of HX, addition of X2. In halogen exchange method we have Finkelstein reaction and Schwarz reaction, okay. Let us revise it again. First, we can prepare haloalkanes from 3 different sources, that is alcohols, hydrocarbons, halogen exchange method. Under alcohols we will study what are the reactions. Then coming to under hydrocarbons we have alkenes and we have alkanes. From alkenes, again we have two things, addition of HX and addition of X2. And from halogen exchange method, we have Finkelstein reaction and Schwartz reaction. I want everyone to draw this. This is what is going to help you during your revision. You just need to see this flowchart and recall all the reactions that you have studied. Okay, fine. Now coming to the first one, that is from alcohols. Okay, so from alcohols, that is ROH, we can prepare by using different reagents. Okay, so first one is by using HCl and ZnCl2. If you use HCl and ZnCl2, we will get RCl. Okay, so what we are adding? RCl group plus water will be the byproduct. Need not worry more about the byproduct. Now to get RBr, we can use NaBr and H2SO4. Okay, NaBr plus H2SO4 will give you RBr, means bromoalkanes. Now here you can use PX3. Okay, in this X is chlorine and bromine, PX3, so to give you RX plus H3PO3. Here I am telling you, in these two cases you need to remember the byproducts. Okay, because here questions are asked with byproducts. So for PCl5 it is RCl plus POCl3 plus HCl. For PX3 it is RX plus H3PO3. Okay, clear? So once again, if we are using PX3 only, then we will get RCl plus H3PO3. If we are using PCl5, then we will get RCl plus POCl3 plus HCl. This reaction, majority of times you should remember the byproducts. Then you can use red phosphorus plus X2. Here again X2 can be bromine and iodine, so we will get RX. Now we can also prepare RCl by using SOCl2. Okay, so this is called as SOCl2. If we use, we'll get RCl plus SO2 plus HCl. Okay, now remember that this method of preparation is the most preferred method. Okay, most preferred method. Now why most preferred method? The reason being is, so I think preferred, I'll correct the spelling. Okay, so this is the most preferred method. Now why this is the most preferred method? Because the byproducts are gaseous. Okay, so that means what? SO2 and HCl are in the gaseous form and they will evaporate. So if they evaporate, only RCl will be left in the container and we can easily get it. Okay, so now how many methods of preparation are there? From alcohols we have 1, 2, 3, 4, 5 and 6. Okay, so you have to remember in this way. From alcohols we can use 6 different ways to get RX. First is HCl, ZnCl2. Okay, second is NaBr, H2SO4. First two remember. Then we have PX3, then we have PCl5, then we have X2 red phosphorus, and then we have SOCl2. 6 methods. Again let us recall. First one is HCl, ZnCl2. Second one NaBr, H2SO4. Third one PX3. 4 PCl5. Fifth one X2 red phosphorus. Sixth one is your SOCl2. Okay, here you should remember SOCl2 is the most preferred method. Clear? Now we will go from, so first is gone. From alcohols we have understood. Next was what? Hydrocarbons. Under hydrocarbons we have alkanes and alkenes. So we will go to the next method, that is from hydrocarbons. So under hydrocarbons, from alkanes, the method, process is called as free radical halogenation. Okay, so what is done here? You have to take any alkane, okay, and then you add chlorine in presence of H nu. Okay, so this undergoes free radical halogenation. Okay, under this free radical halogenation we can get more than one product. We get more than one product. Okay, now if we are getting more than one product, so as you can see this, so what happens, basically a hydrogen is replaced with chlorine. So this hydrogen can be replaced, this hydrogen can also be replaced. So we can get a product like this, we can get a product like this. So we are getting a mixture of product. Because we are getting a mixture of product, this method is not preferred. Okay, not preferred method because more than one product is formed. Clear? This one getting? Okay. Now we will go to from alkenes. Okay, so under alkenes again you have remembered 2 is there from addition of HX and addition of X2. Okay, now addition of HX, if you remember, it follows Markovnikov's rule. Now what is Markovnikov's rule? According to this, the X part of HX, right, HX is there, so X will go to the carbon having less number of hydrogen, and H will go to the carbon having more number of hydrogen. H will go to the carbon having more number of hydrogen. Now if I see this example, okay, CH3 CH double bond CH2. Now if you see, this carbon is there, okay, so the addition takes place on the carbon which is having double bond. So if you see, this carbon is having only one hydrogen and this carbon is having two hydrogens, right? So what will happen according to the Markovnikov's rule? H will go to the carbon having more number of hydrogen. So H will attach here, okay, and X will go to the carbon having less number of hydrogen. So X will go and attach here. So we will get this type of haloalkanes. Okay, now next one is addition of X2. So addition of X2 is what? In the double bond, this double bond will break and we will get two halogens attached to both the carbons which were having double bond. Clear? Again, let us revise till now what we have done. First we have seen from alcohol. Under alcohol we had 6 methods of preparation. First one was HCl ZnCl2, second one was NaBr H2SO4, then we have PX3, PCl5, X2 red phosphorus, and the last one is SOCl2, right? After that we came to from hydrocarbons. Under hydrocarbons we have from alkanes. Now from alkanes it is free radical mechanism. Just you have to take any alkane and then you have to add Cl2H nu. Okay, this is a free radical mechanism, so we get more than one product and it is not a preferred method because we get a mixture of products here. Right. Now coming to alkenes. Under alkenes we have addition of HX, so it follows Markovnikov's rule, and we have addition of X2. This is very simple addition reaction. Double bond will go up and two halogens will be attached. Clear this method of preparation? Okay. Now coming to halogen exchange method. So in halogen exchange method what happens? The reactant itself is a haloalkane. Okay, reactant itself is a haloalkane, and the halogen part is just exchanged. Okay, so under this we have two name reactions, very important. First one is Finkelstein reaction. So in Finkelstein reaction what happens? You take Rx, where X can be chlorine or bromine. That means you can have RBr, okay, you can have RCl or you can have RBr. Right, now you have to take it in presence of NaI dry acetone. Okay, so this one will give you Ri. So I can say we can get iodoalkane. Right, so Finkelstein reaction is for what? To produce iodoalkanes. Okay, now similarly we have another reaction, that is Schwarz reaction. So in Schwarz reaction you take Rx, okay, and then you can treat it with some metallic fluorides. Metallic fluorides like AgF, Hg2F2, COF2 or SbF3. Okay, now if you treat with this one, what will happen? This F will come and metallic halides will form another, so we will get Rf. So this is what? Fluoroalkanes. Right, so I can say that Schwarz reaction is for the preparation of fluoroalkanes. Okay, so with this we are done with the methods of preparation of haloalkanes. Let us revise again. First is from alcohols. Under alcohols we have 6 methods. What are they? The first one is HCl ZnCl2, second one NaBr H2SO4, third one PX3, then PCl5, then we have X2 red phosphorus, and lastly we have SOCl2. From hydrocarbons we have 2 methods, that is your alkanes and alkenes. In alkenes that is free radical mechanism, alkenes addition of HX and addition of X2. Then the third method, halogen exchange method, here we have 2 reactions, one is Finkelstein reaction, another is Schwarz reaction. In Finkelstein reaction iodoalkanes are formed, in Schwarz reaction your fluoroalkanes are formed. Clear? Okay, now going to doing some question. Now allylic bromination is carried out. So this is important question. So now you see, suppose this is there, CH3. Now I can say that this is an allylic carbon. Why is it allylic? Because it is attached to the carbon having double bond. Now if I want to add a halogen here, so I should use NBS, okay, N-bromosuccinamide. So in this case what will happen? Bromine will attach on the allylic carbon. Okay, so the correct answer for this question is option number D. Coming to next question, this reaction is known as, so if you see NaI dry acetone, just now we discussed, right? So it is giving you CH3I for getting iodoalkanes. So for iodoalkanes, what is the name of the reaction? Finkelstein reaction, right? Next, okay, so now we will go to preparation of haloarenes. Okay, so preparation of haloarenes means your aromatic group should have a X present. Okay, aromatic group should have a halogen attached to it, that is called as haloarenes. Now here we have two methods, that is from hydrocarbons and another one is from amines. Okay, so from hydrocarbons one method and the next one is from amines. Now coming to preparation of haloarenes from hydrocarbons, so you can take any, this one you can see benzene with the CH3, so this compound is called as toluene, right, or methyl benzene. Now if you treat it with X2, okay, so here X should be chlorine or bromine, okay, that you should remember. Okay, now you can take it iron in dark, or we can also, this is used as a catalyst, okay, this is used as a catalyst, or in place of this we can also use FeCl3 as a catalyst. Okay, so these two things we can use. So we will get that this X gets attached at the ortho and the para position. Okay, so X gets attached at ortho position, okay, and para position. Clear? X gets attached at ortho position and para position. Now if you see, reaction with iodine are reversible in nature. Okay, so that is why iodine reaction we cannot get iodobenzenes with this, okay, because reaction of iodine is reversible in nature. So what do you mean by that? See, for example, I have this one Ar, okay, X, and here H is there. Now if we treat it with I2, okay, then what I will get? This one, okay, so this is not X, sorry, this is CH3, right? So this is CH3, so here it will be CH3, okay, and here there will be I, and this H will come out and this H will react with another I left, we will get HI, right? Now what happens here? This HI reacts again with this one to give you this one. Okay, so this is what is called reversible in nature. So what we have to use for iodo if I want? So I should use HNO3. Okay, this is a strong oxidizing agent. What will this one do? This one will convert this one to I2. Okay, and then I2 cannot do the backward reaction, right? A forward reaction only will continue. So that is why reaction with I2 are reversible in nature, and we cannot get, you cannot take F2 here because of the high reactivity of fluorine. Okay, so the more easily or very easy to prepare are your chlorobenzenes and bromobenzenes by this method. Okay, next coming to from amines. Okay, so we can prepare from amines. So this is name reaction is there, that is your Sandmeyer reaction. Okay, very important. So first of all, this is your aniline. Okay, this is your aniline compound. It is converted to something called as benzene diazonium chloride. Benzene diazonium chloride. Right? So now what happens? How to convert this to this? You have to use the reagent NaNO2 plus HCHX. Okay, so generally we use NaNO2 plus HCl. Okay, so now what happens? This gets converted to N2 plus and X minus. Now from here we can get bromobenzene or chlorobenzene very easily. You can use the reagent Cu2X2. Okay, if you use CuCl2, we will get chlorobenzene. If we use Cu2Br2, then we will get bromobenzene, right? That part is done. Now to get iodobenzene, we can use, we do not need copper, we can directly react with Ki to get iodobenzene. Okay, so to get iodobenzene, we need to react with Ki, and to get chlorobenzene or bromobenzene, we need to react with Cu2X2. Clear? Okay, now coming to the preparation methods are done. Let us do some questions. Which represents the nucleophilic aromatic substitution reaction? Okay, so it is telling which of the following represents nucleophilic aromatic substitution reaction. So we have X here, and this one should react with a nucleophilic. Okay, so if you react with chlorine, okay, chlorine is reacted as Cl plus. Okay, so this is a electrophile. So this question we can do once we study the reactions of the haloarenes much better. That time again I will discuss. This question let us do now, but again I will discuss at that time. Now benzyl bromide, here also electrophile is produced. Reaction of NaOH, here OH minus is produced, right, which is a nucleophile. So the correct answer for this question is option number C. So I will writing here, will discuss this question, discuss in the next class in detail. Okay, I will add the same question again. Okay, because after studying the reactions we can better answer this question. Okay, fine. Next, coming to the physical properties. So the physical properties, here we are going to talk about 3 physical properties. First is melting point. So melting point increases with the increase in mass. Like for example, if you compare chloromethane, okay, chloromethane, then bromomethane, okay, chloromethane, bromomethane, and then one second, not like this, suppose you, then we have chloroethane, okay, and then you have chloropropane, right. So you see, as down the group mass is increasing, so if mass will increase, what will happen? Boiling point will increase. Now why boiling point and melting point will increase? Now why does that happen? So remember, when mass increases, okay, the intermolecular force, that is your van der Waals forces also increases. So now the molecules become more closely, tightly packed with each other. So to remove them or to evaporate them or to boil them, we need a high temperature. Okay, so that is why melting point and boiling point both increases. Now decreases with the increase in branching. Okay, now suppose you see, suppose we have butane. Okay, so butane we can have like this one structure, and we can have like this also one, right. This both will have the formula of C4H10 H9Cl. Suppose we have a chlorine here, right. So now if the branching, here this is called a branching chain or branch chain, this is called a straight chain, right. So in the straight chain what happens, the molecules can be packed together tightly, but in branching what happens, the molecules cannot be packed better. So if the branching is there, then the melting point will decrease. Okay. Next, coming to density. Density increases with the increase in the number of carbon atoms, halogen atoms, and the atomic mass of the halogen atoms. Okay, so if density is equal to mass by volume, if mass is increasing, density will increase. Next, coming to solubility. So solubility is less soluble in water. So generally these compounds are less soluble in water. Okay, although they are polar, but still they are not very polar molecules, so their solubility in water is less. Next, more soluble in organic solvents. Okay, they are easily soluble in organic solvents. Now solubility decreases with the increase in mass. So if you see this Rx, okay, if I write Rx, so this is my, what I can say, negatively charged, and this is the, so I can say this is the polar part, okay, and this is the non-polar part, right. So if the chain is increasing, the non-polar part is increasing, okay, so that is why the molecule will not, its solubility will decrease in water, okay. So yes, these are some important physical properties. The most important is this one, from where questions have been asked regularly, okay. So now let us go to question and solve them. Of the following alkyl halides, one with the lowest boiling point, okay, lowest boiling point. So first, if you see ethyl bromide, means it has 2. This is ethyl bromide, option number A. Option number B, if you see isopropyl bromide, so this is isopropyl bromide. Now if you see option number C, it is N-butyl bromide. N-butyl means straight chain, no branching, nothing, simple N-butyl bromide. Then if you see this one, this is methyl bromide, right. Now if you see here, there is only one carbon, so mass will be less here. I told you if mass increases, boiling point and melting point will increase. But here, because the mass is less, boiling point will be least or the melting point will be least. So the correct answer for this question is methyl bromide, okay. Now coming to, let us do some practice. So first of all, I will tell you the answer of the last class homework question which I gave you. That is, write the correct IUPAC name of the compound, this one. So we have this one C and here we have CH3, CH3, and here we have CH3, okay, and then we have CH2, and then we have Cl. Okay, so now if I see, first of all we need to find the longest carbon chain, so I can write 1, 2 and 3, right. So with this, if I see, we have on the second carbon we have 2 substituents, and on the first carbon we have chlorine, so it is 1 chloro, so we can eliminate this one, right. So 1 chloro, there is no bromo here, so obviously this is wrong answer, and 1 chloro is there. Now 2, 2, 2, there is only 2 methyl groups attached, right. So this is the primary, this is my main carbon chain, right. So 1 chloro, 2, 2 dimethyl propane, okay. So correct answer for this question is option number A, okay. Now coming to our PYQs, a pair of compounds having the same boiling point, okay. Now see, for same boiling point, the physical structure should, for having the same boiling point, if they are optically different, then that doesn't matter. The physical properties, boiling point is a physical property. So cis-butene and trans-butene will have different boiling points because their packing is different. Now N-hexane and neohexane, their structures are different, their boiling point will different. Benzene and ethylene, 2 different compounds, so their boiling points will be different. Now butane 2OL, butane 2L, plus and minus are there, what I can say, optical rotation, how they rotate the plane polarized light, but that will not affect the melting point and boiling point because it is the same compound, right. So the correct answer for this question is option number D, okay. Next one, the compound A in the major, okay. So if you are giving Br2 in UV light, okay, so if you have seen, it is in the preparation of haloarenes from hydrocarbons, right. So you should remember that this bromine, this will undergo what? If we have studied electrophilic reaction. So now see, this bromine can has, here also it can attach, here also it can attach, but more stable one will be this one because it is secondary and this is primary, right. So bromine will be attached on this carbon. So if we see, the correct answer for this question will be, see, this one is not correct, bromine will not attach to the ring, here also bromine will not attach to the ring. Now this, both the possibilities is there, but major product will be option number B, okay. Major product will be option number B, clear? Okay, next question, which of the following statements is true in case of alkyl halides, okay. So they are polar in nature, yes, they are correct. They can form hydrogen bonds, somehow they can form. They are highly soluble in water, so we have just discussed that they are very less soluble in water. So the correct answer for this question is option number C, okay. Now next one, the compound having the longest CCl bond. So if you see the longest CCl bond, it depends on the resonating structures, right. So here if you see this one, this compound, okay, here it is a pure single bond. See, here it is a resonance is there, so there is a partial double bond here. Here there is a pure single bond, here there is resonance, so there is a partial double bond here. Here also there is resonance, so there is a partial double bond here. So the correct answer for this question will be option number B because it is having a pure single bond here, okay. Okay, next question, the arrangement of the following compounds in the increasing order of their boiling point, okay. So we have bromomethane. So bromomethane, if the structure is CH3Br. Bromoform, structure is CHBr3, okay. Chloromethane, CH3Cl. Dibromomethane, that is CH2Br2, right. So now if you see here, first of all, out of chlorine and bromine, chlorine mass is less, so the third one will have the least boiling point. So all other options we can eliminate directly, but we will see the option. Next one, if you see, there is 1 bromine here, so next one will come here. Here there is 2 bromine, so next one will be 4th, and then here we have 3 bromine, so the last one will be 2. So as the number of bromine, the mass of the compound, mass of the elements is increasing, right. If the mass of the compound is increasing, then the boiling point will increase, okay. So yes, that is done. Now this is a question for you, the reaction of primary alcohol with which of the following will give you purely haloalkanes, okay. So you can see the options and then try this question, okay. Next class I will answer this question, and those who have already known the answer, if you have learnt today's class, that definitely you can answer this question. If you have any doubt, like we'll discuss in the next class, but those who have already done, do not forget to comment down the homework question answer. Okay. So yes students, so that was the end of today's lecture. Let us revise once again today. We have studied today about the preparation of haloalkanes and haloarenes. In haloalkanes, we have seen there are three sources of method preparation. One is from alcohols, then hydrocarbons, and then halogen exchange method. In alcohols, we have 6 methods of preparation. In hydrocarbons, we have alkenes and alkanes, and then in halogen exchange method, we have Schwartz reaction and Finkelstein reaction. Done. Now coming to the preparation of haloarenes, here again we have 2 methods. First one is from hydrocarbon by free radical mechanism, and the next one is from your amines by, that is your Sand-Meyer reaction. Okay, so these many questions, these many practice questions we have done, so do practice them. If you have any doubt, please comment down, and remember, organic chemistry requires a lot of practice. Every day, whatever these reactions we have studied today must be revised today and also in the next class. Okay, so yes, now please do not forget our target. The target is to achieve that 60 out of 60 in KCET chemistry. If you are liking this series, if you are feeling happy to study with me, if you are understanding everything, then please do not forget to subscribe the channel. Okay, thank you for watching, and all the very best for your KCET 2025 examination.